Let's take a look at sample problem 4.11, and it's a limiting reactant problem, and it says iron 3 hydroxide is produced by reacting aqueous solutions of iron 3 chloride, so that's FeCl3 aqueous with sodium hydroxide. Alright, so that's how I make iron 3 hydroxide. What mass of iron 3 hydroxide is formed when I take 0.155 liters of 0.25 molar iron 3 chloride, and I mix it up with 0.215 liters of 0.300 molar sodium hydroxide. Alright, so the first thing we should do here is come up with a balanced equation. So here's the plan that's laid out in our textbook. So it says that from the molarity and volume of each of the solutions, and we were given both molarities and both volumes for each this solution of iron 3 chloride and for sodium hydroxide. Then we're going to use the molar ratio to find the amount of product, the amount of iron 3 hydroxide that forms. And then whichever one is the limiting reactant, that's the one that's going to form the fewer moles of iron 3 hydroxide, and we're going to convert that to mass. So let me show you how I would do it. The first thing I've done, and I've come up with a balanced equation, and iron 3 hydroxide is solid. When I look at the solubility table, iron 3 hydroxide is not a soluble compound, so that's why I put S by it. Anyhow, so we know the concentration of the iron 3 chloride, and we also know the volume. So let's start with iron 3 chloride. So for my FeCl3, let me see if I can fix that. There you go. So for my FeCl3, I have 0.155 liters. And I know that my molarity is 0.250 moles per liter. They gave it to us in big M, but moles per liter is the same thing. So I put in my FeCl3 like that. And I know that for every 1 mole of iron 3 chloride, I have 1 mole, or I form 1 mole of iron 3 hydroxide. So let's put that in there. So if I look, my units cancel out, so liters and liters cancel out. Moles of iron 3 chloride cancel out, and I'm left with moles of iron 3 hydroxide. When I punch that into my calculator, I get 0.0388 moles of FeOH3. There we go. So if I try the same thing with my sodium hydroxide. So now I'm going to work with my sodium hydroxide. I'm going to do the exact same exercise. So I know that I had 0.215 liters of sodium hydroxide, and the molarity was 0.300 moles of sodium hydroxide in 1 liter. And then I go over to my balance equation, and I see that for every 1 mole of iron 3 hydroxide, I have 3 moles of sodium hydroxide. So I'll put that in my denominator, 3 moles of sodium hydroxide and my 1 mole of iron 3 hydroxide, like that. And when I punch all of that into my calculator, I end up with 0.0215 moles of iron 3 hydroxide. And this is a smaller number. 0.0215 is smaller than 0.0388. So this is, or I can say that NaOH is the limiting reactant because it produces a fewer number of moles of iron 3 hydroxide. The last thing they're asking us for is the mass of FeOH3. So the way that I'm going to do that is I'm going to take the number of moles that I have, which is 0.0215 moles of iron 3 hydroxide. And I'm going to multiply that by the molar mass of iron 3 hydroxide. I've already gone ahead and done that. It's 106.87 grams of FeOH3, iron 3 hydroxide, and 1 mole of iron 3 hydroxide. There we go. My units cancel out. And then I'm going to write the answer down here, and I end up with 2.30 grams of iron 3 hydroxide. So there you go. That's a limiting reactant problem. What we had to do was find the number of moles of iron 3 hydroxide first with respect to iron 3 chloride. Then we did the same thing with respect to sodium hydroxide using our balanced equation. The one that produced the fewer number of moles was the sodium hydroxide. And then we used that to determine the final, or the mass of iron 3 hydroxide. So I hope you find this useful.